Dear colleagues, ladies and gentlemen, allow me to present the next three lecturers, the next three colleagues who will present their lectures. And as a first, I would like to ask colleague David Coubet, and let me introduce himself first. Our colleague got the degree of engineer of agronome and then the PhD in evolutionary ecology. He is professor at the National Museum of Natural History here at Paris. He works on biology, society, and relationships, from the analysis of mechanisms and interactions to public policies, formulations, combining ecological and social mechanisms. An original part of his work concerns the development of citizen science, bringing new stakeholders in the public debate, providing biodiversity observations, indicators, and scenarios. So please, dear colleague, the floor is yours.
Thank you, Mr. Chairman. So it's an honor to talk in this room, from this front of this assembly. So I will talk about territorial management of natural resources, challenges for the Anthropocene. So the subject is quite large. So I will begin with the notion of Anthropocene, which is a notion which appeared among scientists quite recently. There are two basic ideas. Okay. So there are two basic ideas about the Anthropocene. The first one is that we have now significant human effects on the biosphere, on the environment, in regard to climate change, biodiversity losses, soil degradation, air and water pollution. These are sort of the aspects where, in fact, we have really large-scale effects. And the other idea behind Anthropocene is that we could have possible future large-scale disruptive social consequences. So this is really a notion which brings causes and also consequences, and we have to look at these two at the same time. In regard to social consequences of the Anthropocene, obviously agriculture is quite concerned. In fact, front of unpredictable and varying climate, aridification, concerns also about soil fertility, pollination, biological controls of weeds and pests. So there are now a lot of new problems facing agriculture in the Anthropocene. The other economic activities, obviously, are also quite concerned about the Anthropocene. And what is expected are major losses linked to heat and cold waves, floods, health consequences, people relocation. These are the sort of consequences which we have now to take into account. The other point is also the increasing possibilities of disruption, that is social and military conflicts. And for example, Syria, we know that the civil war, one of the event reported was aridification in 2011. So in any case, agriculture is at the forefront of causes and consequences of the Anthropocene, as the previous colleagues already said. So, which means that for the Anthropocene now we have to rethink, in fact, what are the major challenges for European agriculture. And for European agriculture, we can think that we have three different challenges. One of them is food access, healthy diets, quantity and quality. For quantity, we know that the question is quite complicated. We know that one important aspect will be production resilience, facing unpredictable future global change. That's not much the volume production, which is the issue, the present volume production, but it is more the resilience of this production volume, which is important. The other point is about diets, healthy diets, and we know that now we have major problems also involved with diets, and we know that, in fact, the risk posed by poor diets, in fact, are also an important health problem. The second aspect is about satisfactory and fulfilling livelihoods for farmers. This point was already brought up, and I think I will come back to this point, which I think is an important point, which means that what should be the objectives? I think that the objectives in terms of jobs and also in terms of labor productivity, it's also a very important question. We have just to remind that we have more than 1 billion farmers at the world level. And among these 1 billion farmers, most of them are in Africa and in Asia, and the farm size is already decreasing, which means that they have a lot of problems, and Asian and African towns might not be ready to absorb all these farmers which could be put out of work. Here we have also social disruptions which could come. And the other point, the third challenge, is providing ecosystem services. We know that ecosystems now that not only provide food, but they have also other social importance in terms of air and water purification, climate regulation, local and global carbon storage, also local flows of water, disturbance mitigation. And these are very important economical and social issues. And the problem is it possible to get a triple win? And what I would like to explore today is the possibilities offered, in fact, to get a triple win with what we call multifunctional landscapes associated with diversified farming system. I will use these two terms alternatively. These two ones correspond. That is, to have multifunctional landscapes, you need to have diversified farming system, and the other way around. An advantage with these ones is that they provide a diversity of ecosystem services. So the ecosystem services I talked just before, and the ones which are quite exposed now with the Anthropocene. The other important point about multifunctional landscapes is they are adapted to unpredictable, fast environmental and social changes. Why is it so? It's because you have both biological and social diversity, and biological and social diversity are very important when, in fact, we have unpredictable events. So we have to think about diversity, and biodiversity is biological and social. There are two sides of it. So I will look at this multifunctional landscape with three challenges, three questions that I will explore: an economical one about market regulation, a technical one associated to jobs. I will come to the job question again. And jobs, it's not only qualified jobs. I think agricultural research is also involved in what is the fate of non-qualified jobs. And we know that it is right now a very important political question, in fact, the fate of these non-qualified jobs. And I will talk finally, quite briefly, about social norms. So for economical questions, economical challenges, I will explore two questions. The first one, are multifunctional landscapes and diversified farming system an important economical issue? Or is it just a social issue for just citizens and so on? Or is it important from an economical viewpoint? And the second question I will explore, do we need new economical regulation to extend, to get, in fact, these multifunctional landscapes? So for the first one, there are a lot of work, of scientific work on that. I will just remind you this scientific study published in the most prestigious journal, which is Science. And what they did, in fact, it was a bunch of economists and ecologists, and they compared two scenarios. And they compared the economic efficiencies of, in fact, of mono and multifunctional landscapes at the scale, the horizon of 2060 in the UK. And the two scenarios, it was a lot more complicated. I'll just simplify the work. They compared a scenario which they called national security, that is emphasis on agricultural production in monofunctional landscapes. Environmental regulation is weakened because environmental regulation is not in favor of maximization of agricultural production. So this is the first scenario. And the second one is the scenario they call, this is the term they use, nature at work. Nature at work, that is, they insist on ecosystem services, for example, carbon storage, and there is emphasis on multifunctional landscape. And then they try to make an economical comparison, which is obviously quite complicated. But the economical comparison is quite clear. That is, there are massive collective benefits in favor of the scenario nature at work. They give numbers which is 10 billion euros per year. So it is very important. It's a very important difference. And they didn't, in fact, count all the economical advantages of the scenario nature at work. So I would like to insist, in fact, that it is an important issue, that is multifunctional landscapes have the possibilities to bring major economical advantages. So I will explore now the second question. The second question, that is how you, how you enforce diversified farming systems. That is, the word green economy has been used, and in fact, green economy is really the term which is very important to think of when we think about multifunctional landscapes and diversified farming system. And for this green economy, I would like to insist on three principles. The three principles, the first one, the rules of business must be changed. It has been said a lot. Pavan Sugdev, for example, the head of UNEP, told it. He was also, well, I won't elaborate on that. And he has this, I think, this very interesting sentence: as biological species evolve in response to natural environment, business has to adapt to the Anthropocene. In fact, the problems with Anthropocene are different, so we need to change the business rules. It is quite logical. The second principle, which is very important, this is the Porter hypothesis. Porter hypothesis, what is it? It is that, in fact, environmental regulation brings economical benefits, brings financial benefits. We all know that, in fact, when you are in the luxury industry, you have a lot more benefits when you are, in fact, in low quality production. And in fact, it's the case for agriculture. You will have more benefits with high quality agriculture than with low quality agriculture. The third point is that how you regulate, for example, how you emphasize multifunctional landscapes. Do you make prohibitions, laws, or do you try to make market-based instruments? We are, in fact, facing farmers are entrepreneurs. As they are entrepreneurs, market-based instruments usually are more efficient, because they are more in their logics. So we have to think, in fact, in terms of market-based instruments. In terms of market-based instruments, we have payments for ecosystem services. Payment for ecosystem services is really an interesting solution. We want to emphasize, in fact, ecosystem services, so it makes sense, in fact, to pay the farmers for these ecosystem services. Okay? And there is a classical example now, which is the case of water purification. Water purification, big cities are interested in this, in fact, in this service. And we know that now New York, Beijing, in Europe, München have in fact developed systems of payment for ecosystem services, and it works quite well. That is, it is for one time, it's not always the case, it is a win-win contract. It can increase significantly more farmers' revenues. In China, for example, it has been quite spectacular, and it is in fact a low-cost solution. A low-cost solution, for example, in New York City, it was 6 times less expensive than to build plants for water purification. So it's really an economical, interesting solution. Which means that, in fact, we might be facing a new revolution in regards to agriculture, that is, in regards to the social contract between agriculture and citizens. Basically, it was for the 10,000 years before now. It was about the food system, that is, agriculture provides food, and citizens buy food from farmers. And in fact, with ecosystem services, we have a sort of a larger social contract. We get more complex, because in fact, agriculture then provide ecosystem services, and it's a very important economical question. And obviously, citizens have to pay for these ecosystem services. So it makes sense to have this reciprocal relationship between agriculture and citizens. Okay, so I will stop here now for the economical question. I will come now to the technical questions, techniques and technological questions. So what are the issues? The issues, well, they're quite complex. That is for diversified farming systems. So we talked about the history of agricultural research just before. I think that one important point now is that ecological sciences are coming now in agricultural research, and it's going to make, I think, a huge difference. So this is sort of agricultural research view from ecology. And in fact, you know, you have different scales. You have the plot scale, the field scale, the landscape scale, and then here you have the functions. The function you have to manage nutrients, water, soils, pest control, pollination, and then at the middle, then you have the landscape management. What are the elements? What you can do, in fact, about varieties and landscape, managing landscapes and varieties and fields. In fact, to get these ecological functions and to think as these different spatial scales. So here we have quite a complex, and we have to think about techniques in all these things. That is about mixed varieties, crop rotation, hedgerows, riparian corridors, how you enforce natural areas. You have a lot of complex technical questions about these five questions. So I think that one point that is for companies, for economical actors, it's going to be quite challenging. And I will just talk about 2 examples. That is about soil fertility, pest control. That is, the future might be that, in fact, companies, economical actors will have to manage soil and plant animal microbiomes, weed and pest predators communities. That is why we have to go. We might go from a good economics, in fact, where economical actors were providing goods like fertilizers and pesticides, where they will provide in the future services. That is, they will be here to manage the soil fertility, to manage the weed control, the pest control, which is quite a different economy. So it makes a lot of challenges for these companies. And for plant breeding, we know that we need local breeds adapted to local needs, mixed varieties, mixed crops, relevance. Also, we need additional genetic diversity with all varieties, sexually compatible species, which makes also a new horizons for plant breeding. And we have, in fact, to develop these farmer seeding systems with associating companies and farmers, which, for example, participatory plant breeding, new selection schemes. Here also, we have a lot of challenges in regards to plant breeding, where, in fact, economical actors might change quite a lot in the future. One thing I would like to insist also about techniques, because sometimes we hear discourses where, in fact, we have techniques on one side and politics on the other side. Things are a lot more complicated because there is a lot of scientific stuff between the techniques and the politics. That is where a lot of social rules, and the social rules determines what are the technologies which are developed through their relative advantages. So the social and economical rules, we have to look at them very carefully, and there is a lot of science to make about these rules, how to change these rules to make them more proper so that we develop the adequate technologies. And it concerns, obviously, plant breeding, weed and pest controls. So these new rules, now we have to think of the social incentives. What should they be based on? They should be based on life cycle assessment performances. Obviously, that is very, very simple. I just put sort of numerous an example, a joke about the drones. But for example, are drones or relevant techniques? Then the question is, what is the energy use, the emissions? Are they competing with other beneficial use of battery? That is the important question we have to ask about these new techniques. And also, an important point which is also often forgotten, which is Jevons paradox. That is when you develop a more efficient technique, as it was shown in the 19th century, you can have impact on the demand. You can, in fact, increase the demand, so that in this case, the environmental efficiency at the field level might not be environmental efficiency when you look at the biosphere example. So it's quite well known in economics, it's a classic in economics, and for example, when we develop new breeds, efficient breeds, so that you can develop field crops, for example, in the Mato Grosso, even though the field, at the field level, it is environmentally efficient, then if we develop these fields in the Mato Grosso, is it really environmentally interesting? Do you bring environmental and social progress? You have to look at this rebound effect. It's very important. 5 minutes? Okay. So that's something which is very important. We have to look at these different criteria and social rules to derive from these criteria. What are the interesting techniques and which ones are not interesting? In regard to techniques, we have to look also at the job question. The job question. Just to remind us that we lost almost 5 million jobs in European agriculture since 2000. 60% in the new member states, 93% for corresponding to non-salaried workers, so often unqualified jobs. And obviously, when I talked about diversified farming system, an interesting question, can they bring, in fact, new jobs? Can they stop, in fact, the loss of jobs? And it's a very important social and political question. For this question, obviously, I have not the answer. I think it's too early. The only figure I found, which I think is interesting, is something related, which is about ecological restoration. Ecological restoration, now it's an important economical activities, especially in the USA. We have a law about ecological compensation, which has been in force for quite a long time. And what is very interesting is that, in fact, the number of jobs, it's more than 100,000 jobs now in ecological restoration. And you can see that the number of jobs is more important than in coal mining, in logging, in iron and steel mines, and it's not far from motor vehicle manufacturing. So it begins to be a very significant economical activities. And we have to think about, about these multifunctional landscapes that they can bring also a lot of new jobs. Okay, so finally, I will finish with the social norms. The social norms that concern citizens and consumers. Thing which I think is very important that we have to think, and agricultural research is quite concerned about that, is that social norms can change very rapidly. They can cross what we think in terms of system research, they can cross tipping points. That is tipping points, that is a norm, there is a certain norm, at one point it begins to be another norm. And in this case, the behavior of consumers and citizens can change very rapidly. So we have to think about these tipping points with regards to how the consumers are going to change, to choose in the future in regards to food price versus quality, in terms of diets also, for example. Are we going to the present diet, which is what we call the income-dependent diet, where in fact you eat more meat when you have more money? Will they switch, for example, to Mediterranean or pescatarian diets? And we have a lot of effects, in fact, on markets and also on the farming sectors, and also what will be the concerns about environmental and social impacts of agriculture in the future for citizens and consumers. And so I will conclude that we have, in fact, I will come back to this figure, we have three related challenges for agriculture and Anthropocene. And I insist, I think that techniques and jobs might be a very important question to consider in the future. Thank you for your attention.
Thank you, Dennis, and we have now space for a few questions.
Erwin Bartsch from the Hungarian Academy of Sciences. You haven't mentioned the problem with the aging of the farmers in the developed countries. So, what is your opinion about how we can solve this serious situation? Because most of the farmers are quite old, and the young generation are not really interested in to go to the agriculture farming system.
Thank you for the question. It's not my specialty, so you have sort of difficulties to answer. What I can say from the French example is that it means that it seems, in fact, that diversified farming system is quite attractive for young farmers. So, in fact, it might be a way, in fact, to attract young people to farming. It might make it more attractive. I think there are also some figures in USA. Also, it is also quite a tendency right now. I don't know about Eastern Europe, but I suppose that it shouldn't be far. It's not that different from France and USA.
Yeah, there was a question.
I think I have in mind. Lisa Senneby Forsig, KSNA from Sweden. When we're discussing the sustainable development in the future, the concept that is always coming out is the circular economy. You didn't mention that here, but can you say a few words about that?
Okay. Circular economies are a lot of words to be used. Life cycle assessment is about circular economy. That is, you want to reduce the life cycle impact of the products, which means you want to go to circular economy. So it was about circular economy when I talked about new rules, in fact, to enforce circular economy.
Fascinating talk. Can I take your name? Excuse me, Malcolm Hadley, I'm associate member of the Academy here. Can I ask you how you would link up your statement that the rules of business must be changed? Business has to adapt to the Anthropocene. Second point that you made is how do we go from providing goods to providing services? How do you react as a shareholder of Bayer and Monsanto to providing that change, of changing business practices, of not being so much focused on goods but on services? What do you say to the boss of Bayer about that?
Well, I think that Bayer knows quite better than me the subject. And I think they're already switching to service economics. As far as I know, there are some tendencies and they communicated on that, in fact. So it's already on, I think it's already on the process. Sorry, it was not understandable.
I have one question.
What's your name again?
Farmers' knowledge.
What is your name? What is your name?
Please present yourself.
That's right.
Your name.
Goran Alexis, Georgian Academy of Agricultural Science.
Okay.
Okay. The question is the level of the farmers, knowledge of the level of the farmers, at least in our countries. I mean, Georgia, Armenia, and these countries, Central Asia countries are very low. What science should do to increase the level of the knowledge? Several years ago, it was some studying this question, and they studied in Georgian condition. It was the German specialists, and they told that the knowledge of the farmers, they are receiving the knowledge from their parents only, not from the scientists. What science should do for this? What ways are for this?
Thank you. That's a complicated question. I come from the museum where there's a lot of anthropologists, and anthropologists, in fact, they work on traditional ecological knowledge. They work, for example, on Indians in Amazonia, and they see that, in fact, Indians know quite well how the ecological system functions. Whatever, I think that traditional ecological knowledge exists also. That is, your farmers, they have some knowledge, and they need to hybridize, in fact, this knowledge with scientific knowledge. But I think that you should be careful. You don't want to replace one type of knowledge with another type of knowledge. What you want to enrich the knowledge, to hybridize the different knowledges.
Sorry, we can allow one more question.
Munolu again. With your last slide and the triangle, do you still believe in sustainable development?
Well, that's an interesting question. I think that if market regulation and social norms change quite rapidly, and there might be tipping points, in fact, well, in fact, it could go quite fast. In fact, we could change quite rapidly. And for example, when you look at the fossil energy market, where in fact the coal companies now are going disrupt, and we can wonder about the oil companies, we can think, in fact, the market can change quite rapidly. So it can be the same case in agriculture and so on.
So thank you once more. The second presenter will be Jean-Charles Munk from Munich University. He was nearly 20 years chairman of soil ecology at the Technical University Munich, Germany, and head of the Institute of Soil Ecology at the National Research Center for Environmental Health in Munich. Before, he was head of the Institute of Soil Biology at the National Research Center on Economy in Braunschweig, Germany. He was studying agrobiology in Strasbourg, France, and Stuttgart, Germany. And I have here a short remark that you, Jean-Charles, are just retired.
Thank you very much. Thank you for the opportunity to speak here. You see, we are two authors. Rainer Matisek was invited. He is actually in China and so on. And this is why I have now this presentation. And Biota supported soil management. You will see I focus especially on agricultural soils. What is not so well known is that soils are habitats. Soils have a high density of microorganisms, and you see 10 billions of bacteria, archaea, per gram of soil, and so on. And I compare also here with the human, not only the human genome, but the human microbiome. And you see in 1 gram of soil, we have 1,000 more genes that the human microbiome has. And these details are not well known, but you see here from Vinogradsky a picture from 1949. The picture is older, but was published in this book, where he's shown soil is a habitat. A lot of organisms, microorganisms are habitating in soil, but this knowledge was never really used and not really used in agricultural practice with a few exceptions like nitrogen fixation and so on. And you see soils are products of a very, very long evolution, depending, of course, about the local conditions that exist and so, and this complex soils that is formed, we have here a lot of some details. Also here with the organic soil, organic matters, that is a produce of the transformation by microbes of the primary organic matter from plants. And without this formation of humus, of soil organic matter, without feeding microorganisms to produce continuously, the stable structure of soil will disappear in a very short time. And microorganisms are located, of course, in these pores of soil. You see here different dimension of pores, and also on roots, because roots are feeding also the microbes by exudates. You see here the density of bacteria of a root of mice, or on the colored picture, this is confocal laser scanning microscopy, where genes of some bacteria are labeled, and here we can distinguish the name of the different bacteria here in association, not also with the root. This is the actual state of this kind of research. And the faunal intestine is also a nice habitat, because the conditions there are more constant and so on. So we have extreme heterogeneities of ecological conditions, and these conditions here, the microorganisms, only a few are active, most are inactive, are dormant, and become active when the soil needs their activity and so on. Also by giving free energy for actives and so on, by dying by virus and so on. And the activities, the services microorganisms are providing in soil are complex. Yeah. A lot are well known and so on, were named also in the previous presentation and so on. And for example, what is very important actually is the degradation of antibiotics from husbandry and so on, because there is no real regulation of these antibiotics and so on. And soils function only with these microbes. And I will just show a few actual possibilities to get an insight in this microbial world and in the life conditions. You see here in computer tomography picture, or it's not a picture, it's a data sample to a picture that show the pores in an aggregate. We have, we can go in more details. These are 2 centimeters. We can go in the millimeter scale to get such an insight on the real habitat of microorganisms in soil. Also with the hydrological conditions, with the aeration in the aggregate, with the amount of water as life real habitat, the water and so on. And so we get this insight. On the other picture, you see these red points. These are bacteria on the root that are actually in dialogue with the root. They are producing homoserine lactone, one of the chemical dialogue molecules. And so we can recognize the microorganisms that are actually active with further labeling of genes. We can also recognize the kind of microorganisms. And so this is the scale where we are working actually. The picture on the soil aggregate is very new, 2-3 years old, where the techniques to show microorganisms and also to demonstrate different actual gene expressions by the microorganism is given since 10 years and so on. And you see also the possibility to use this potential for production of plants and so on. Now, as a scale, we are working a lot actually with remote sensing, of course, at different scales and so on. And also in Germany, we try actually to have 2 satellites with radar wavelengths where we have a resolution at the soil at 30 centimeters, and we can work, analyze soils and so on, maybe worldwide, where we have partners. And here I ask, is it necessary to have such techniques for soil microbiology? This is a picture we have, for example, here. It's a corner open. This is yeah, maybe nearly a yield map. This is the density of farms density of plants on our research farm, where we have also education of farmers. We invite regularly farmers to show what we are doing and so on, what techniques we are using. In Bavaria, this is not big farmers, but they are co-working, buying the big equipment together as a well-informed about the actual possibilities. And the other one here is the soil analysis by radar techniques, where we show a high heterogeneity in all these fields. And we use this knowledge for a better management. For example, the tractors are GPS positioned and manage the soil according to our knowledge on different soil conditions. Yeah. And now I come back to soil microbiology. We have one of the fields on this farm, very heterogeneous, 8 soil formations and so on. And we are showing details in the soil for here now for 3 points. So water field pore space is very important again for biology, because we get insight in water content and in aeration at different scale. And this is a combination of remote sensing, of field analysis, and of mathematical modeling to have this development of soil moisture for 1 year in a depth of 90 centimeters. So to get insights not only in available water for plants and so on, but also insights in the habitat for microbes. Yeah. And this is just the illustration here. What we are doing, of course, analyzing the microbial communities in these different soils here for different points of this field. Or here, one of the detail, these are population of methane producing microorganisms in this field. And we see at some parts on the left, the typical picture in the upper soils, the upper 10 centimeters, we have more microbes and we have a higher diversity of microbes than in the deeper part in 40 centimeters. But in this case, this is a waterlogged part in the field, we see we have the high density of these microbes in the deeper part of the soil, not in the upper part where we have more organic matter. And we try to understand the functioning of this community, of these populations and so on, by using data from remote sensing techniques and so on. Now, why is this biota in soil? Soil is a life habitat that is very heterogeneous, especially in time. We have seasons, we have managements and so on. And it is very important for the functioning of this very complex system to have a high diversity of microorganisms, so that each time the microorganisms that are necessary for the functioning of the soil and so on becomes active. Yeah. I told some are dormant and so on, but for all this constellation of conditions, we have the microorganism in soil, and if some people mean this is a too high biodiversity, this is not the case. The heterogeneity in time and space and so need this high biodiversity, and the soil has to be feeded to have this high biodiversity. I think here about crop rotation and so on, and not monoculture. And now our soils now are endangered politically by farmers are under economical pressures and so on. We lost a lot of soils, agricultural soils, for urbanization and so on. And we may have also desertification by climate change. And we need appropriately a management of soil to conserve the soil, to reduce negative impacts and so on. And we have to use better this microbial, these biological resources we have in soil, that we understand more and more. It was impossible 30 years ago to know more that biomass of microorganisms and to have knowledge about a few strains, and so that we were able to cultivate. A part of the world soil are not usable, a part are forest soils, and only 1/3 of the soils may be used for agriculture. Most are grassland soils, of course, also are used for food production and so. Nearly 12% are arable soils. And as this little part of soils of the world, we have to conserve it and to be active. And I will just show a few examples, one examples of the destruction, not only of soils, but of the habitat of microorganisms in soils. I can also speak about organic matter. And so when we remove also plant residues, for example, removing straw from wheat to produce ethanol and so on, we are not feeding this microorganism, and the structure of the soil will fall down very rapidly. And one of the problems, of course, is when pores disappear, one of the problems is also the retention of water that is limited. If we have less pore space, we have less water retention in the soils and so on. And these are well-known images. The equipment will be heavier and heavier in Germany, where plants for energy are now very modern and so on. We have transport system with 60 tons and so on, and with a very high compaction of the soil. The harvester are bigger and bigger and so on, and we have compaction in the soil not only in the upper centimeter, but more than 1 meter depth and so on, where there is no tillage and so on. We know about soil grabbing in poor countries. Actually, or I've seen last year, the calculation is 83 million of hectares that are bought by other countries. And Europe uses 32 millions of hectares outside of Europe for producing food for Europe, for producing feed for the husbandry in Europe, for producing especially plants for energy and other raw materials. And this is also a part of the politic of the EU, for example, in Africa. And one of the consequences is the price of agricultural soils that will be higher and higher here. Development over 10 years in some countries. And in some countries we have a regulation about the prices, in others not, and this is why we have also these differences. And you see this is a global problem. These are not only a few countries that are grabbing soils, there are a lot of countries, and some countries, poor countries, are the goal of this grabbing. And now another aspect, climate change. I will not speak about temperature and so on. We will have here in this room in January a presentation about anthropogenic ozone. This is ozone in the troposphere, where we have actually crop losses in agriculture of 10 up to 20%, depending about the region. This is ozone that is formed in region with high air pollution and so on. And the second aspect I will show is an example from northern latitude, where in future we will have a higher air humidity. And you see the background in northern latitude, this higher humidity. And colleagues in Estonia have established a field system with humidification of the atmosphere in the forest. You see here a few details again, and I will just show a few results. Here you see the soil water potential that is different also, because we have less evapotranspiration. The soil will have a higher moisture, and here in the upper part I have the soil respiration that fall down also. This means that we have less organic matter in the soil, we have less respiration, less transformation, less mobilization of nutrients in the soil, and a total transformation also in the soil. Of course, we have more details from the colleagues. that flow that is different, we see that the consumption of water is different and the soil will have a higher moisture that may be negative. And also effect, of course, on the plants. And so I hope I have showed that soils and soil ecosystem as the basis of our life and so on, they are endangered by different causes, also by climate change and so on, and we need a European initiative for the protection of soil. And this may be also by the Union of the European Academies of Agriculture. And we have no legislation in Europe. This is a private actual initiative against the protection of soils in Europe. And I think we need more than this. Thank you very much for your attention.
Thank you very much for your presentation. And we have a little bit longer time for a discussion. So please, who is interested to discuss or ask our lecturer? Here.
Zero's the Paris Ukrainian Academy of Science. Thank you very much for your good presentation. And I have a few short questions. Do the farmers interested in your research? And do the farmers ready to pay a little bit for this research? And what the contact with farmers do you do for them some analysis? And so do you have a lot of projects with farmers?
Yes, the farmers are showing at first at economical points. Yeah, they have to survive and so on. They are interested in new developments if there is interest in economically for the farm. Yeah. But it's not for all. We are in discussion with farmers that try to conserve the soil for the next generation and so on. Yeah. They ask about knowledge. How will I better manage the soil to conserve the soil fertility, to conserve the soil? And it is so that, of course, most of the farmers, especially the farmers that have not the chance to sell products on the farms that are not near to a town and so on, they are doing conventional agriculture with a few plants, with destroying the soil. And I would propose that at the supermarket, the price of the food will be higher with a compensation for the farmer to have a kind of agriculture to conserve the soil. For example, to have a crop rotation, including leguminous plants and so on. And this should be a political decision. Europe can propose such thing. One country in Europe will not propose it because the price of food on the global market is less. And I think for the future generation, it is essential to conserve this basis of life, of production of food for the growing population. And this is not functioning without costs for the consumer, for all consumers, not only for the farmer, but especially for us, for the consumer.
Thank you. Next question. No. Extraordinary case. Okay.
Norman Hadley, forgive me for speaking for a third time. A fascinating talk, and I think you underline how here in Western Europe, since the war, what we've done to our soils is an absolutely diabolical action. I mean, we have considered our soils as black boxes. No, okay, something to grow plants on or graze animals on. And what happens below the surface, we're not interested in that. We'll knock all these animals out with our pesticides, herbicides, etc. And so thank you for drawing attention to this action on our part as agricultural community, what we've done to our soils. Can I ask more tangibly, how do you encourage farmers that have got soils that are essentially without life? How do they try and bring back those soils into a living system? What sort of encouragements, subsidies, etc., would you give to them?
It's very difficult in some region of Germany, not in whole Germany. Farmers are encouraged by the politician financially to turn to biological farming. Yeah. But I think you have to be convinced on biological farming to do it, and so there are a lot of insecurities. And since the price for bioproducts were very high, and now the production in eastern country for bioproducts let fall down the prices. We are not sure if all these products are really products from biological agriculture. Yeah. And this is a new risk for biological agriculture. And on our farm, I have shown we have biological agriculture, we have integrated farming and so on, and I would not say it's the best. It's biological farming. Yeah. I have a lot of knowledge about also problems on biological farming. Yeah. But farming with a crop rotation and so on, using also this potential, a new product is biocontrol. Instead of pesticides, we can use biological products, we can buy them on the market and so on. Yeah. And have another form of agriculture with respect for the soil and so on, but I think it's not, we can convince some farmer, especially also that we'll have a real heritage for the children, the possibility to live also on this farm and so on. Yeah. But without the pressure from the politic, without a new kind of agriculture, we have here it also in the previous talk, and so nothing will really occur in sufficient amount and so on. And this is here, we are here to discuss this.
David Gardner, Royal Agricultural Society of England and Innovation for Agriculture. Really picking up on the last question.
So that the camera.
Sorry, yeah, sure. Really picking up on the last question, and also actually going back to the previous paper we had just before coffee. We run a program to encourage farmers to improve the biology within their soils. I think the interest, there's a lot of interest in it at the moment. It's been partly driven by the yield plateau. There are situations, certainly where in the UK, wheat yields haven't risen for many years. And I think farmers increasingly recognise that their soils are exhausted. In terms of what we encourage them to do, we encourage them to broaden rotations, to import livestock manures, to use cover crops, catch crops. In some cases, to bring livestock back onto the farm. There are large parts of Eastern England now, and certainly large parts of Germany and France that have no livestock, or regions really. So we encourage them to bring livestock back on the farm. Increasingly, minimal disturbance of the soil when they drill, so keeping the biology at the surface, reducing compaction, control fat trap farming systems. But it goes back to the previous paper just before coffee, when there was a comment made that things are getting much more complex. And the sort of things that we talk about with the farmers we work with are about changes to the whole farming system. And they really don't suit the scientific world very well. In that most of the science that's been done in the time that I've been a farmer has been very sort of one-dimensional. It's been we apply a fungicide, we don't apply a fungicide, we get very clear results from it. The sort of practices that farmers who are leading this charge in the UK are practicing, they're changing their whole farming system, their cultivation system, their rotation, crops they're growing. Some of them are very flexible in terms of the rotations they grow. They will make a decision about what crop to grow next almost until the day they're going to drill it and make a decision about what they're going to do. and it doesn't really fit the scientific world very well. They're not, they're very expensive experiments for anyone to do them, and they're over such a long period of time that by the time you got the result, you have a different question anyway. But we have a number of farmers in the UK, and we're in touch with farmers in Belgium, in Holland, who are also experimenting on different ways of farming that are addressing the very issues you're talking about. And it's quite an exciting space, and at the moment in the UK, it's just the farmers who are leading the thinking, rather than the scientific community who are leading the thinking in terms of tackling the problem that you've identified. So not really a question, just a point.
Thank you. One more question? We can now one more question. If not, maybe I will ask myself. Could contribute to this team also some, let's say, agroforestry practices?
Oh, my colleague Rainer Matisek is from forestry. But I can add one aspect. You see here also, for example, we are working on effects on ozone on the forest, actually on effect of high dryness, and so because here in Bavaria we have the problem of less precipitation, or not less, but as a distribution of the precipitation, yeah. And so, and you have in the forest, you see the grain and so well equipment. What we are doing in farming is agroforestry, with strips of wooden plants, and so in fields with different aspects. This has also to do with soil moisture and so on, because we have a protection against the wind and so, and less evapotranspiration and so on. And we will see after a few years, I think 19 years at maximum of wooden plants in the field. After that, it would be a forest. If we have also in these strips a better rooting, a deeper rooting, and a better use of the nutrients in the soil in a bigger soil volumes that will be explored. So on. This is I retired, but of course my former workers are active and so on. And also one farmer near our universities that is working on biological farming is showing about the development of such system, because actually we can use these wooden plants for heating. We have new, in the past it was difficult and so, but now a lot of houses are heated with so-called renewable resources, also with wood and so on. And the farmer, if they use not this wooden plants, can sell. And so it is interesting for the farmer to do it also. Yeah. Also one aspect of protection of agricultural sites.
Thank you very much. So, in this moment, I would like to finish our discussion. We can proceed to the last presentation of the block of this session. I would like to ask Vaida Giza from Latvia present. Vaida Giza is an agricultural economist. She is currently the president of Latvia Academy of Agriculture and Sciences and vice president of Latvia Academy of Sciences. He works as professor at Latvia University of Agriculture.
Yeah. Thank you for the introduction. Dear President, dear guests, this is really a very great honor for me to be here, and I am very thankful to the organizers about this meeting. And you see, I also put one sheet about this, how we experienced our history, and you see that we are very proud that 153 years ago there was established agriculture education institutions. At first agronomists started to get the diploma, and this is the background. These are the roots of our University of Agriculture in Latvia, and we celebrate 3 years back. Very nice this event. And you see also that in 1910, that we can see here, then the first research and education center was established in Latvia, and that means that, and also these agricultural societies even earlier, officially it's 1906 But of course, there are many different, maybe smaller research groups who are working with the potatoes and also with the grain, and to do some research to develop their in the university in their interests, how to proceed in the future. And my task today is to tell how our academy in Latvia, how we support researchers and also farmers, how we are working for the better outcome in the research. And my academy in Latvia, Agriculture and Forestry Sciences, we were founded in, you see, soon it will be 25 years as we are. It's a rather young institution, and this was built the 800 scientists that it's necessary that we will have such academy. And in Latvia we have officially in the law 2 academies. We have this Academy of Agriculture and Forestry Sciences. This is why we have this name Latvia Academy of Agriculture and Forestry Sciences, and the General Academy. And you see, we have today we have 137 members. 100 are Latvian doctors. For full member, you must be the doctor of science, and we have 15 abroad members and 22 honorary members who are not all scientists. There could be also good farmer or maybe also politician who get. Who work together with and support us, and so it's 22. But after approximately, after 12 years we worked, and we worked very actively with the Academy of Sciences, Latvia Academy of Sciences. And after 12 years, the general meeting of the Latvian Academy of Sciences, they say yes, it will be good if we will have also department of the agriculture and forestry science. And from this 2004, we are working very strongly together. The General Academy, Department of Agriculture and Forestry Sciences, and Academy, the Agriculture and Forestry Sciences. And I think that this very good solution that we manage to put together these efforts. And I can say in this process of the development new department in our Academy of Sciences, it was very good support from our Lithuanian colleagues, Lithuania, because they had such department, and Zenonas is he is the chair of this department. But somehow it was really very good that in this 2004 Academy general meeting voted and say yes, that we will have such department. And we are, as a General Academy and also Academy of Forestry and Agriculture, we are personal academies. That means that there is no link. We are not. We are under us. We haven't the research institutes as such, because all research institutes after reform, they are in the universities, or there are 3 separate state research institutes, but others are in the universities. That means that we are, as personal academy, I am as president writing each year project for the money for these activities. I'm going to the we have special farmers organization union, and I'm telling what we will do. Do the farmers organization support us? And if you say yes, it's good what you are planning, we see the results, and so then the minister signs that okay, there will be the money. The General Academy is going through they have this agreement with the Ministry of Education and Sciences. We Agriculture Academy with the Minister of Agriculture. What we are doing, we are each month meeting when the colleagues are coming together, and we are doing them together with the Academy of Sciences. Academy of Sciences, the Agriculture Department, together with the Presidium of our Academy. And then there are a lot of seminars. We are working also with international projects as together with the Academy of Sciences and also separately. There you can see some seminars. For example, ICE seminar, it's supported from Swedish Institute, and we are there 9 partners, also Baltic countries and Poland. And also we are very happy that we are now as a representative as Academy of Sciences in the David's project for D4F, but we listened yesterday, and as I said, and I again it stressed that this is real all ours product, because this network is coming from our union of this our agricultural academies, and I think this is very good that it is so, and I hope that we will work hard and it will be not only one such project. So, and we are taking part also in different other activities, and many, but I want to stress 2. One is this competition sower, and this is organized by the Ministry of Agriculture in this next Friday. It will be in Latvia. This is beautiful, beautiful event when the ministry thanks the best dairy farmer, the best the potatoes grower, new farmer, for example, and also researchers. And there is 1 year is the category new scientists, that these who are defense the dissertation of the 2 years period, or experienced scientists. And this is diploma. There's also money, and this is beautiful event with the music and dinner, and state president and prime minister and ministers are always there, and ball and dancing, and really nice. And we are very happy that we are very actively working with this evaluation. And the same is also about, this is agriculture, same is also for forests, forest scientists and forest owners and so. And then the other point what I want to stress, especially this is we worked a lot with the doctoral students, and we are listening them before defense in our meetings, and also the Academy of Sciences, they have the duty according to the laws that all PhD thesis before defense, they are sending to Academy of Sciences, and we are checking them. The experts are checking them, are they ready for defense, and only after we say yes, they can in the universities defend the PhD. And this is very responsible and I think duty for us, and we are doing it. And why we are working so much with the doctoral students, we are trying also to help them in this to go to conferences. We involve in the projects, and we are supporting in different ways. And you see that from one point we need the new scientists. We need new scientists because 57% are of our scientists, they are older than 65 years, and that means we need new one. And also 67% are only on state budget doctoral students. Others are paying themselves. And that means that this payment is rather high. Of course, it's different in different branches, but it is very important that we try to support our doctoral students, and also as we need these young scientists, we worked a lot with the ministry how to support them after the defense. And I think that this is our academy is also a result, effort result that in this period, 2014-2020, in the European funds for Latvia, we have special grant for young scientists. We have for young scientists. And that means that you can apply in 5-year period after defense, And the grant is for 3 years, and this is rather high. It's actually higher as professor's salary. It's 2,300 euros per month. But of course, there also are everything that you need. There could be also reagents and going to the conferences and also the fee for the articles and all what you need for your job. And you can apply in the 5 priorities. 5 priorities. And you see the first priority is bioeconomy. And I can say in Latvia we have very strongly the government push us to the bioeconomy. And energy, innovative materials, technology, IT, public health, these 4 are also for the previous time, but bioeconomy, it's the new one, and that's very strongly, it's developed very strongly. And why it is so? And we can say that really there are reasons why it is so. And because as also was mentioned here today, that bioeconomy, this is one of the challenge, and for us, for sufficient foodstuffs and renewable commodities, and for all this, also energy, this is one of the challenges. And how it is in Latvia, and we can say that in Latvia we are good competitive advantage in it, and the contribution of bioeconomy sectors of the value added of all the goods produced in Latvia is 55%, and it is we can say that it is a high contribution of the bioeconomy sectors. And if we look on the export value, it's 39%, and it's made by the forestry wood products with the agriculture, food, and together it's 39%. It's also a large amount, and I think this is the reason why the government also decided, Cabinet of Ministers, that bioeconomy is the priority for Latvia. And if we look how we can use all this potential for the bioeconomy, that of course there is this multidisciplinarity, that we need to more multidisciplinary to look at our research results. Then innovation, and to try to help entrepreneurs to develop the ideas, to help them start the entrepreneurship, and to consulting them. And on this process there is very strong point for the universities, and also of course for the Academy of Sciences. And I will tell you that first how this multidisciplinarity is working. And this is working from the national research programs. And we have 4 national research programs who link with our branches. This is agriculture, food, forest, and environment, and economical view how to do what is the best result, what we can get in the end. And the innovations and how to help with the entrepreneurs. This I will show you through our Latvian University of Agriculture, as we have only 1 agriculture university in the country, and veterinary medicine, food, engineers are only in this university. These are unique for these branches. This university is unique for green branches, and you see that we really worked a lot with the different exhibitions, events, success stories telling, and also consulting, a lot of consulting. We can say that we have you see, we have each 6 years the professor's re-election, and for this re-election you need to show how many scopus you have, how many doctoral thesis defense, and also it is necessary to show how you are dealing with practitioners, with farmers. How do you have some agreements? Do you help somehow? It's important. And it's also push us to work more hardly. But I will tell you here just one example from many. That young lady young lady, she came to the Faculty of Food Technology, and told that she had small baby, Rudolph's, and he was very allergic, and he started to make at home different such baby products from fruits and vegetables as puree. And she wanted to tell about this experience to other mom, because they maybe also have such problems. And then Faculty of Forestry, together with the Fruit Growing Institute, and also pediatrics from the University of Medicine, they worked together, and they worked for 2 years. They made research how to better do it, how it will be very good. And then she started to do it in incubator in the university. And in this moment, after a year, there was the announcement from the European Union that the eco products, the entrepreneurs can start to develop eco products, and she was ready to write the proposal, and now she started entrepreneurship started with 3 million euros. This is practical, that from zero in 3 years you came till the real production. And this is really helpful for the university and for the scientists. They helped her because he was not no technologist in food, but this is the real result, common real result. And such examples are many, and we are very happy about it, that there are scientists, professors, doctorates, together they do it. And I can say that in our academy's work, we are very strongly linked on this helix model, that we work together, academy, that's university, ministry, private sector, media, we are telling about our success, and also non-governmental organizations. And I say you that in Latvia we have association of all farmers organizations. That means the dairy farmers organization, the apples and potatoes and processing and advisors and forestry. They all are together in one association, and we are also there. Each month we are coming to this association meeting and telling what we are doing. And my money, on my academy money, strongly depends what this non-governmental organization will say. Are they support us or not? And that's, I think, also influence us to work together with the farmers. And in the end, I am very happy, of course, that we are proud that we are on this golden October 2000 in Florence, and we have this, take part in this beautiful meeting, and I hope that we will be again there after some time. And when we founded this our association, and we have the presidency in 2008-2010. We organized the conference, and we had also the book. I hope that that French colleagues also will do it. And also the second seminar, we have a conference and seminar in this time. And I can say, from my side, I can say that our association, of course, these are the main 4 points from my side, and that it is increase empowerment and partnership possibilities, and also information and sharing experience. And in the end, I can say that trust, respect, friendship, this is very good for working together. Thank you.
Thank you very much, Maivan. This is excellent conclusion of our session, as mentioned by Michelle. But we have still space for several questions, remarks. Yeah.
You will ask in the lunchtime.
Thank you very much. Journalist of the Academy of Science. Thank you very much for your presentation, for your good activity of your academy. But I'm surprised that what is the future of agriculture research? I'm surprised that your scholarship for PhD students very small. Do you have the PhD students enough in your country and to the young people interested in research, because not being supported in your country.
Yeah, that's good if you will write also minister this message that is rather small as in Litauen. Yeah, that's really, you see, we had, it also was the efforts of our academies that before we have EU stipend for the doctoral students, and this was 900 euros in the third year and 400 in the first and second euros. But in this period, for this period, we decided that we will support young scientists, that these who had the defense, because we need that they will stay in Latvia, not move to England, for example. but you are right. The stipend is really very low, also to compare with the neighbors. And we wrote the letter. Now we are trying to involve them in our national research programs, and all doctorates, they are in some programs that they are getting some additional money. We can send them the conferences and to make the fee. We are trying, this is a responsibility for each professor that his or her doctorants are in the research, are in the grants. So that's how we support them.
Next question will be from Michelle.
Thanks, Dave. I appreciate your presentation. It was interesting indeed. I have one question I would be interested in, if you have the answer. I'm not sure. That's why I asked you a question. Do you have an idea, do you have any assessment of the impact of research that has been in your country on those, let's say, those last 20 years or so? Do you think that the investment that you have had for those, like, let's say, 20 years approximately, on the agriculture in the country, do you think there is possibility to have an assessment of that? And if it is, what is the, again, the level of impact of that research on agriculture?
If you are looking to the results, that of course also in our country in these last years there's growing that how many milk we have from cow, what the yields are, and of course this is the result of the scientists, because we are working with the new different varieties and help farmers with the each spring there is a months-long these lectures when the scientists are going around and invited to the research farms and institutes, the farmers, and tell this grain is this, and this is get so much minerals, and this more, and this is better for this is better for that. I think this is our part, scientists' part in this growing agriculture and developing. Also for these innovations, as I told that we are trying to help a lot books. Each year we have we organize academies the 10 best research results. These could be results of the project, these could be books, and again it's nice event that we are inviting the president and all ministers, and show that in Latvia these are the 10 best results, and always among these 10 are also agriculture researchers, always. That's I think that we feel strong, but if we see the support from the state, actually in these years, when we are in Europe, the most support is coming from Euro funds, not from states. The Euro funds money is higher to compare with the state money, and scientists, they are really afraid what will be after 2020.
Thank you. One question here.
Thank you very much. Hold on. Can you introduce yourself to the camera here? To the camera first? Your name?
George Yasin, President of the Academy of Agriculture and Sciences, Romania.
Go ahead.
Thank you very much for your very interesting presentation. Your country has two neighbors, Lithuania and Estonia. in my opinion, these three countries have more or less the same problems. Do you cooperate with them and how?
Yeah, yeah, we are three neighbors, three pearls near Baltic Sea. We can say yes, we really cooperate. We are really strongly cooperate because each year the presidents of the academies of all three countries and also Scandinavian countries, Finns and also Swedes, we are coming together for the meeting, and also we have these. Grants, we have agreements between among these academies that we are sending scientists to their labs, and we are cover expenses, their expenses to, for example, Litauen and Estonia from our side, and they are sending again to us the young scientists or these changes. And also if there are some conferences or projects or something that really Lithuanian colleagues or Estonian, they invited us, and we are trying to invite them. That this is a very long story and very traditionally this coming from generation to generation that we are really strongly together. There is also some competition and a lot of jokes about the neighbors. As Rizonanos is here, I will tell one. The Latvian and Estonian, Latvian Lithuanian colleagues, they are scientists drinking beer, and Lithuanian say to Latvian, "Oh, you are so lucky. The Riga is so beautiful, and girls, and even Nordic neighbors are better." But Nordic neighbors for us, these are Estonians. But for Litauen, we, and they say that even Nordic neighbors are better. That means we are not so good, actually. So.
Right. So I was asked to stop the discussion at present. We can continue in couloir. And let me conclude this session and give the word to Michel.
Thanks, Willem. Just a few things for housekeeping, so to speak. First of all, please be back at 2:30. We will start at 2:30 sharp because, again, we have another meeting after this meeting at the Student County meeting, so we have to be on time. So, first of all. Second, you can leave your belongings here. It is safe. Make sure you take your wallet in case you might need it for staying your food, but otherwise it will be safe. So you can leave your belongings here. So we wish you bon appetit and see you at 2:30. Thank you.